Hello friends, my name is Coach Veer and you are watching YouTube channel Coach Veer, and in this video we are dealing with a different topic. Topic is differential equation, and in the differential equation specifically we are going to talk about Picard's iteration method, as you can see on the screen. And this method you can say as Picard method of successive approximation. It is the approximation method, like a numerical analysis method. So if you have not liked my channel, please put a subscribe click and a bell icon click. After that you can put a like also. Thank you friends. So let's start with this method. So this method is utilized for problems which are differential equations of the form dy by dx of any function y which is in the form of f of x comma y. Like this side we have x and y both types of terms, but we require an initial condition for that, that y at x naught is equals to y naught. Means when x value is x naught, y is going to become y naught, and that is the initial condition, like the starting step for that whole graph. Let's proceed how to solve problems and what formula we need for solving these kind of problems. So the solution is very simple. Like if you want to find y of x, you just need to put y naught, the initial condition, plus x naught to x f of x comma y dx. You need to just integrate this part and substitute it. Like when you are doing it for the y1, that time you just need to plug in y naught here plus x naught to x and f of x comma y naught. And if I tell you like this way, if you're going to do yn, it depends upon how much accuracy you want. If you want very much precise, you go to more n values. So y of n of x is equals to y of naught plus integral x naught to x. Let me write the lower limit and the upper limit, and then inside this function in place of y you just put y of n minus 1, the previous accurate value of y which you have got. It is successive approximation method, means you require every step output. Okay, and then we can arrive to a sequence of approximate solutions like y1 y2 y3 yn, and depending upon your accuracy requirements you can go up to desired value of n. Let's try one example so that we'll be more clear about this. Suppose we got a differential equation dy by dx is equals to 2y negative 2x square, let's say negative 3. And suppose the initial condition is y at x equals to 0 is giving you output 2. How are we gonna solve this? So first of all, we know that y naught value is 2 and x naught value is 0. That's our initial point. Now the formula of yn, which we know, is y naught plus integral x naught to x f of x comma y of n minus 1 dx. Now y naught we know, so suppose we can write it as y of n as 2 plus x naught, also we know it is 0. Upper limit to be put it as x, and this one you can write it as, I'm just writing it as function of x comma y n minus 1, or what else you can do is you can write it as 0 to x and function is this part. So 2y n minus 1, this is in the subscript, negative 2x square negative 3, and everything is inside this bracket and needs to be integrated with respect to x. Let's talk about the first approximation. Now we are going to do the first approximation. So n value should be 1 here. So we are going to get y of 1 is equals to 2 plus 0 to x, and in this we are going to put 2y naught minus 2x square negative 3 and everything inside bracket, then dx. Now y value is very much sure, y naught value is very much sure, that is 2. So let's substitute 2 in place of y naught. Like let me write it again here, y naught is 2. So when we substitute it, the first approximation will look like 2 plus integral 0 to x, 2 times 2 is 4, negative 2x square negative 3. or you want me to write it as 1? That will be better now. So let me write it 1 here. 2 plus integral 0 to x 1 minus 2x square dx. Why I'm saying 1? 4 minus 3 is 1. That's why. Now it's quite easy to integrate it. Let's do the integration work. Y1 equals to 2 plus integrating this, we are going to get x minus 2x cubed by 3 bracket close, and then we require the limit 0 to x. 0 substitution will not have any impact because it's going to be 0 only. So y1 we are going to get 2 plus x minus 2 by 3 x cubed. That's what is our first approximation. Similarly, if you want the second approximation, what you are going to do is write second approximation. Then y2 is equals to 2 plus y0, which is 0 to x, and now that function 2yn minus 1, correct? I'm not writing it again. You know this y0 is to be put it as y1, so I'm writing it here 2y1 negative of 2x square negative 3 everything inside bracket dx. Now this y1 needs to be substituted in this place. Let's substitute it and see what will happen. 2 plus integral 0 to x 2 times this whole thing. Let's do the multiplication here. So 4 plus 2x minus 4 by 3x cube negative 2x square, this negative 2x square, and this negative 3 dx. Can we simplify this stuff a little? Yes, 4 minus 3 is still 1 that we can do. Okay, so let's do this part and arrange it better way. So 2 plus integral 0 to x 1 plus 2x negative 2x square. I'm just arranging it 4 by 3 x cube. Hope you are getting it till here. If not, please put it in the comment. I will answer it. And now let's do the integration part. So integration of 1 is x, integration of 2x is 2 times x square by 2, negative 2 by x cube by 3, negative 4 by 3 x to the power of 4 by 4, 0 to x. So 4 get cancelled, 2 get cancelled, and we need to substitute the values. So we get 2 plus this opening of bracket will surely give you x, because 0 putting 0 in all of them is just 0, so does not make any sense here to write it again. Let's write the x part. X square negative 2 by 3 x cube negative x to the power 4 by 3. That's our second approximation. Hope till here it is clear to you how we can generate the second approximation. Similarly goes for the third approximation. Let's write the third approximation. So when we do the third approximation, we get y3 is equals to 2 plus integral 0 to x 2y. Now not it's not 1, it's less than this, so y2 will come. Okay, subscript 2 negative 2x cube negative 3. This whole thing is integrated with respect to x. Now y3 is equals to 2 plus integral 0 to x. That is what I'm going to write. Now substitute the value. When you substitute, 2 is to be multiplied with all of them. We are going to get 4 plus 2x plus 2x square negative of 4 by 3x cube negative of 2x to the power of 4 by 3 negative 2x square. Let's write square here, negative 3, and then everything is to be integrated with dx. Let's simplify a little, just like 4 minus 3 and something else. So 2 plus integral 0 to x 1 plus 2x. This 2x square and this negative 2x square get cancelled, and this thing we are going to write the same, 4 by 3 x cube negative 2 by 3 x to the power 4 by 3. That's now everything is to be integrated with respect to x. Let's do the integration part. So we get x plus 2x square by 2 negative 4 by 3 x to the power 4 by 4, negative 2 by 3 x to the power 5 by 5. Everything has a limit from 0 to x, lower 0, upper x. Now 0 have no meaning, as I already suggested, so we are just going to write 2 plus x. This 2 get cancelled, so x square. This 4 get cancelled, so negative x to the power 4 by 3, negative 2, let's write it 15, 5 3 is 15, x to the power 5. That's our y3, or simply if you don't want further, then simply y. That's the better approximation, or the third approximation. Similarly, we can try different questions, and whatever is good, we will do it in our next video. I will put more examples like this in my coming video, because I am going to put more and more type of examples related to this, and then we will move to the next topic on this, like hypergeometric functions and the existence and uniqueness theorem, paraffin equations and all. So this is all for this video. See you again in my next video on this episode. Till then, bye bye.